Okay, so in this video, we're going to look at 1.7, which is the measures of center and location. And so this was a lot of vocab talking about, and I'm just going to go down to the vocab first, population versus sample. So remember that population is a large group of people that you're trying to collect data and make a conclusion about. However, you can't talk to all of them. So you take a sample. So that's a subset of that population. And then whatever you're collecting is your data is either going to be a parameter or a statistic. So if I was able to collect data on the whole population, then that's called a parameter. If I wasn't, then that's called a statistic. So I believe in the notes, he used an example of like a company, right? So if I want to know how many hours everybody in my company works on average, I can look at, timesheets and find that value and average that together. Versus if it's a sample, I can take some people from my company because I don't want to look at all that data and find that average and then use that to describe the population. So if it is actually everybody in the company, it's called a parameter. If it's only a group of people in the company, it's called a statistic. And then the other thing that was important there, besides they talked about like finding the median and the mean, was whether a measure was resistant. And so if something is resistant, it's not sensitive to extreme values. And so the median is resistant. So if I have outliers, they don't affect the median. The median is still the middle. They're not swayed by that value. However, the mean is resistant. So if I have an extreme value, so I have a bunch of data that's close together, and then I have a really low number, that's going to bring my mean down. And then if I have a bunch of data close together and I have a really random high number, then that's going to bring my mean up. It's going to increase it. So a low extreme value decreases my mean and a high extreme value increases my mean. The very last thing they talked about was how the mean and median compare on the different distributions. So for a skewed distribution, the mean and the median are different. For a symmetric distribution, they're usually the same or close to being the same. So the mean and the median would both be this value. This includes the mode as well. So the mode is always the highest peak. And so that should be the same in a symmetric data set. It also talked about if it is skewed left, the mean is to the left of the median, or the mean is smaller than the median. And then in skewed right, it's the opposite. So the mean is greater than the median, or it's skewed right because the mean is to the right of the median. Okay. And so those were some properties in the vocab that was discussed in that video. I just wanted to go over a quick example finding the mean and the median of a data set using a frequency table. So I'm going to go through that last. A frequency table is another way that you'll see the data displayed in the problems. So if we think about a frequency table, we can turn that straight into a dot plot. And so this goes 6, 7, 8, 9, 10. The frequency just tells us how many dots there are. So there are 2 6s, there are 3 7s, there are 7 8s. I almost didn't leave myself enough room. And then 7 9s. And 1 10. Okay, so if I'm thinking about that and I want to find the mean, remember the mean is the sum of all the data values divided by the number of data values. So if I want to find the number of data values, I would add up the frequencies. And so if I add up the frequencies, that's going to give me 20. So that tells me that I have 20 data points. And then to find the sum, what I want to think about is the sum would be 6 times 2 plus 7 times 3 plus 8 times 7 plus 9 times 7 plus 10 times 1. And so that sum will be 162. Okay, so I can just type that in my calculator. 6 times 2 plus 7 times 3 plus 8 times 7 plus 9 times 7 plus 10. Right, and so that gives me 162. Which means that the mean of this data set is about 8.1. Because I have 20 numbers, one way to think about the median is, so if I have 20, that means if I split that in half, and so what that means is that I'm going to have 10 numbers on either side of my median. So 10 numbers on each side of the median. So with my dot plot, I just need to count 10 dots. So my first dot, 6, right? 1, 2, 3, 4, 5. 6, 7, 8, 9, 10. So that's 10. I should have 10 on the other side. So let's double check. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means that the median is here between two numbers of 8. So that means that the median is the value 8. So notice that I didn't have to list all my numbers in order, that I can visually still use the dot plot to tell whether or not to find the median. I can do the same thing for a stem plot. So there's no reason to list out all of those 6 through 10 numbers to find the median or the mean. Okay, so that was 1.7, which is the measures of center and location.